This question is a calculator question. And you would tell on an exam, because on the exam they put a little calculator icon right beside the question saying you have to use a calculator to solve this one. But if we were solving this, a couple of things tell us it's a calculator question. To the nearest hundredth usually means that you're going to be using your calculator. And when I combine my like terms in this equation, so I'm going to move my cos x to the left, I'm going to move my 6 to the right, divide both sides by -3. I get cos x by itself, and it's -2/3. And 2/3 is not a value that we have on our unit circle. So because of that, we're going to need to find our reference angle. So take out our calculators, make sure, because our domain is in radians, make sure that our calculator is in radians, and we go cos inverse of +2/3. I'll just write that down. Remember that when you're finding your reference angle, you're always doing the inverse of a positive value, and you get 0.841. And now cos is negative. We know from our cast rule that cos is negative in quadrant 2 and quadrant 3. So in quadrant 2, you're going to do pi minus your reference angle. So I get 2.3 to the nearest hundredth would be 2.30. And in quadrant 3, it would be pi plus my reference angle, which is 3.98. Put off to this, I'm going to put above this one that this one was an answer in quadrant 2. This is an answer in quadrant 3. And this is all answers again, just making a note of this, this is all of our answers between 0 and 2 pi. Now that we've done that, let's go back and say, is that what they were looking for? No. In this case, they were looking for answers between -pi/2 and 3pi/2. So if we think about that, well, that would be answers in the positive direction from 0 to 3pi/2. Can you see that that would hit quadrant 2? And these answers, this answer in quadrant 2 would be the same. And since it goes to 3pi/2, it would hit quadrant 3. And so this answer in quadrant 3 is fine. We also have to look from 0 to -pi/2. Can you see that that's quadrant 4 in the negative direction? And with quadrant 4 in the negative direction, we have no answers in quadrant 4. So even though the domain was changed, our answers happen to be the same as our answers between 0 and 2 pi. Usually on the exam, if they're going to change the domain, they're not going to change the domain so your answers don't change, because then they can't check if you actually thought about that or just did it from 0 to 2 pi and didn't check. But in this case, they are the same. Then write the general solution. So now that we've got our solution, we can write out our general solution. And your general solution says take all of your answers. Wow, worst squiggle bracket ever. That's better. Take all of your answers between 0 and 2 pi, which is 2.30 and 3.98. Add 2k pi, because we're dealing in radians here, where k is an integer. Perfect. Scroll up to look at part B. To the nearest degree, solve the equation root 2 cosecant x equals -5. With all of your reciprocal trig functions, cosecant, secant, and cotangent, if you have an equation with them, just like sine, cos, and tan, we want to get the trig function by itself. So I can get cosecant by itself by dividing both sides by the square root of 2. And once you get your reciprocal function by itself, you can then change to your regular function. The angle doesn't change, but cosecant is the reciprocal of sine, so that means that sine of x will be negative root 2 over 5. Again, this is a calculator question because root 2 over 5 isn't a value on our unit circle. So we're going to need to find our reference angle by doing sine inverse of positive root 2 over 5. And this question is in degrees, so we have to go to our mode button on our calculator and make sure that we're in degrees. So now when I do sine inverse of the square root of 2 divided by 5, I get a reference angle of 16.4. It says to the nearest degree, so I'll round that to 16 degrees. Sine is negative, so that means it's in quadrant 3 and quadrant 4. If my reference angle is 16 degrees, 180 plus 16 degrees, this is my answer in quadrant 3. And 360 degrees minus 16 degrees, this would be my answer in quadrant 4. Again, these are all answers between 0 and 360 degrees. Again, I look at the domain that was supplied for us. And our question was looking for something between negative 180 and 180. So if we look at our positive answers first, we're looking between 0 and 180, which is quadrant 1 and quadrant 2. Our answers are in quadrant 3 and quadrant 4 that are past 180. So I'm just going to put a line through those because those are not part of our solution. Our solution will include, well, what would be coterminal in quadrant 4 with the same reference angle of 16 degrees? That would be negative 16 degrees. What would be the one that's coterminal with 196 in quadrant 3? That would be negative 164 degrees. So how did I get the negative 164 degrees? Okay. I personally like to still think about my reference angle and say if I'm going in the negative direction and I have something in quadrant 3, that's like quadrant 2 in the negative direction, I would go 180 minus 16 to get 164, and then I would label that angle as negative. So that's what I did. I said, well, all the way to here is 180, minus 16 degrees is the reference angle. That'll give me 164, so I'll have a negative 164. You could have also taken 196, which is here, and subtracted 360 to go around backwards. I personally find the mental math of 196 minus 360 more difficult than 180 minus 16. So that's why I prefer 180 minus 16 to get 164, but you could also do 196 minus 360 to find the coterminal angle in quadrant 3. So there are our answers between negative 180 and 180. Now if we're writing the general solution, Again, the general solution says find all of your answers between 0 and 360 or 0 and 2 pi first. So I'll use those, 196 and 344. And since we're dealing in degrees, to write all the coterminal angles, we add 360 degrees times k, where k is an integer. Questions to do for practice with this are 6 and 7.